Hello students, today we are going to start the JEE numerical Zener Diode topic. Here I have drawn a two circuit. We have to find out in first circuit the current through the Zener Diode, that is IZ divided by IZ. Okay. First of all, in this circuit we have given one resistor, one low resistance, one diode and one battery. Okay, battery voltage that we have given 120 volt, and here the Zener Diode voltage is given 50 volt. Okay, but here in ground state it is 0 voltage, here is also 0, but in upper side it is 50 watt, here is also 50 watt. Okay, what we need to find out first of all, the current passing through the load resistor. Okay, that is denoted by IL. Okay, so IL is nothing but, according to Ohm's law, V upon RL. What is V? That is 50 watt. And what is RL? That is 10 kilo ohm. So 1, 0, 1, 0 is cancelled out. So 5 into 10 power minus 3 ampere. So here you can write 5 milliampere. Okay. Now here what we need to find out another, that is V naught, that the potential difference across the 5 kilo ohm resistance. So that is the total potential 120 minus the Zener Diode potential, that is 50 watt. Okay. So answer is 70 watt. Now we need to find out the current which is passing through this resistor, that is suppose I guess I. Okay, so I is nothing but it is the V upon R. Okay, now what is V here? That is V naught, that is 70 volt, and R is 5 kilo ohm. So answer is 70 upon 5, that is 14, 10 power 3, so 14 milliampere. Okay, minus 3, 14 milliampere. Now what we need to find out? The current through the Zener Diode. So I is equal to, we can write the total current, that is, it is divided from this junction. One current is passing through the Zener Diode and one current passing through the low resistance. Okay, so here you can write IZ plus IL. Now I, total current, we already know that is 14 milliampere. Okay, and IZ is, that we need to find out. And what about IL? That we already find out, 5 milliampere. So the answer is IZ is equal to 14 minus 5, that is 9 milliampere. Okay, so total current passing through this Zener Diode is 9 milliampere. Hope you understand this question. Now in next numerical we have to find out the current from the Zener Diode at minimum and at maximum. Okay, so here the battery voltage is changed from 8 volt to 16 volt. Okay, so first of all we need to find out the minimum current through the Zener Diode. We take 8 volt as a battery voltage. Okay, now first of all we need to find out the current which is passing through the low resistance. Okay, so we can start. So IL is equal to VL upon RL. Here RL is nothing but, VL is nothing but, it is the 6 volt. Here is 0 ground voltage and here is 6 volt. Here is also 6 volt. So VL is 6 volt. Now RL is given, that is 4 kilo ohm. Okay, so here it will cut. So 3 by 2, that is 1.5. So 1.5 milliampere. Okay, 1.5 milliampere. Now the potential across the resistance R1, that is 1 kilo ohm, that you have given. So here we can write V1 is equal to the total voltage, that is VB is 8 volt and the Zener voltage, that is 6 volt. Okay, so answer is 2 volt. The potential difference across the resistors R1. Okay, so here we can find easily the current I, okay, which is passing through the resistors R1. Okay, that is V1 upon R1. So what is V1? That is 2 volt. Then after, what is R1? That is 1 kilo ohm. Okay. So it's plus 3 come to denominator side. So answer is 2 milliampere. Okay. Now what we need to find out? We have to find out the current through the Zener diode at minimum. Okay. So here we can write clearly I is equal to IZ or IZ plus IL. Okay, so I is nothing but it is the 2 milliampere. IZ as it is, that we need to find out. IL is, that is 1.5 milliampere. So IZ is nothing but it is the 2 minus 1.5 milliampere. Now that is 0.5 milliampere. Okay. This is JEE main exam numerical which was asked in 2019. Okay. So for minimum, the current passing through the Zener diode, that is 0.5 milliampere. Now we can find out from the, at maximum voltage. Okay. We can apply here for battery. Total voltage is 16 volt. Then we need to find out the Zener diode voltage at maximum. Not voltage, it is current. Okay. Now for next, we can find out the maximum current which is passing through the Zener diode. So here we can apply 16 volt to the battery. Okay. Now we need to find out again, that is IL VL upon RL. So VL is nothing but here is 6 volt and RL is, that is 4 kilo ohm. Okay. So again it will answer is 1.5 milliampere. Okay. Now but here the voltage across this resistor, that will be different. So here we apply 16 volt, that's why. Okay. So 16 minus 6 volt, the answer is 10 volt. Okay. Now the current passing through the circuit, that resistance is I is equal to V1 upon R1. Here V1 is 10 volt, R1 is, that is 1 kilo ohm. Okay. Means 1000. So 1, 0, 1, 0 get cancelled out. So answer is 0.01. Okay. 0.01 ampere. So here you can write 10 milliampere. Okay. Now the current passing through this Zener, that is written as, again we can apply the junction rule same as it is. Okay. That is I is equal to total current IZ plus IL. Now I is 10 milliampere, IZ that we need to find out, and IL that you already know, that is 1.5 milliampere. So IZ is 10 minus 1.5, that is 8.5 milliampere. Okay. Hope you understood. Thank you. Okay, next, other 3 example that you have given from the same topic, Zener diode. Okay, we need to find out the current which is passing through the Zener diode. Okay, again we can apply the same methodology. First of all, we need to find out the current which is passing from the 2000 ohm resistance. Okay, let us start. Suppose I guess I2 which is passing through the 2000 ohm resistance, and at ground the potential will be 0, and at top that is 50 watt and 50 watt, which is nothing but which is the resistance of the, voltage of the Zener diode. Okay. Now V2 by R2. So V2 is nothing but 50, R2 is 2000. This will cut out, this will also cut out. So 1 upon 40 is 0.025. So here you can write 25 milliampere. Now the potential across this RS resistor is nothing but it is the total potential, means battery potential minus the Zener diode potential, that is 50 watt. Now we need to find out the current which is passing through this resistor, that is suppose I guess I. So I is equal to V upon RS. Now V is 50 watt and RS is 1000. Okay, so 1, 0, 1, 0 is cancelled out, and the answer is 0.05, means 50 milliampere. So the current which is passing through the Zener diode is I is equal to IZ plus I2. Now I is nothing but it is the 50 milliampere and I2 is nothing but it is the 25 milliampere. So IZ is 25 milliampere. Okay, so this is the answer. Fine. Now in next numerical, now the next we can find out the current which is now the next we can find the current through the Zener diode. Okay, the resistance that we were given R1 and R2, the battery voltage that we were given 12 watt. Okay, so how do we do that? Let us start. VAC is equal to VAB plus VBC. Now VAC that is 12 volt, VAB that we don't know. Now VBC which is the potential across the Zener diode, that is nothing but it is the 10 volt. So VAB is 12 minus 10, that is 2 volt. Okay. Now the current passing through this resistor R1, okay, that is I1 VAB upon R1. Now what is VAB value? That is 2 volt. And what is R1 value? Which is given 500 ohm. Okay. So this is the current which is passing through the resistors R1, that is 4 milliampere. When you simplify this, you get the answer 4 milliampere. Similarly, you can find the current through the resistance R2, that is I2 and VBC upon R2. Now what is VBC? That is 10 volt. So 10 upon R2 is 1500. Now we do this further calculation. So we get the answer, that is 6.7 milliampere. 6.7 milliampere, which is not possible. Why? Because see, I2 is greater than I1 here. In our answer, I2 is coming which is greater than 6.7 is greater than 4 milliampere. See here clearly the current that we have already found, that is 4 milliampere. Now 4 milliampere further divide from the junction B. So it will not more than 4 milliampere. Okay. So here the answer is 6.7 milliampere. Okay. So we get the answer is more than 4 milliampere. Okay. So current will not pass through the Zener diode. Okay. Now the next we need to find out the current which is passing through the Zener diode. Okay. So Zener diode. Now the next in third numerical, now the next in fifth numerical. Okay. Now in fifth numerical we need to find out the current which is passing through the Zener diode. Okay. So again we can apply the same methodology. Okay. This VA. Now the last sum, we need to find out the current which is passing through the Zener diode, that is IZ. Okay, so similar method we can apply here. First of all, we need to find out the total potential, that is VAC, that you already know, that is 16 volt. Then after VAB, then VBC. So VAC, that is 16 volt, VAB that we need to find out, and VBC, that is 10 volt, the Zener diode potential. Okay, so VAB easily we can get 16 minus 10, that is 6 volt. Now we need to find out the potential, so the current across the RS resistance. So I, that is VAB upon RS. So VAB is 6 volt and RS is 2 kilo ohm. So this will cancel out. So 3 milliampere is the current which is passing through the RS. Now the total current is I is equal to IZ plus I Okay, next we can find out the current which is also passing from the RL. Okay, so that is I L is equal to VBC upon RL. So VBC is nothing but it is the same potential as the Zener diode potential because both are in parallel. That's why. Okay. So 10 upon RL is 4 kilo ohm. So here we can calculate. Then the answer is that is 1.5 ampere milliampere. 1.5 milliampere. Okay, now we do the further calculation. That is I is equal to IZ upon plus IL. Now I is nothing but it is the 3 milliampere and IL is 1.5 milliampere. Now we do subtract these things, I minus IL. So we get the answer, that is 3 minus 1.5. So 1.5 milliampere is the answer. Okay, thank you.